Morning, everyone. This morning, Mike State was going to give us a walkthrough of the multisig contract in rholang.
Yeah, I'm super happy that Mike will join us today and talk about this. Yeah. Hello, Mike.
Hi, I'm just getting my desktop ready for sharing.
Okay.
All right, can you see this?
Yes.
So this is just the code on GitHub. The idea was to use Artur's design for auth keys and show how to use that to enable people to wrap rev vaults in other contracts. One of the other constraints was that contracts needed to be able to form multisig vaults as well. And so for that, I resorted to using sealers and unsealers, which are a design pattern that in OCAP secure languages lets you do the same thing as public key cryptography without needing cryptography. So I'll just start here at the beginning. Multisig rev vault is the contract that we're going to expose. This is registry for sticking something into the registry. This insert signed. So we're going to be putting the multisig rev vault into the registry. Lookup is for the other things that we depend on, like list ops and auth key and rev vault. These are some internal methods and some channels that we use to retrieve things from the registry. So here we look up our dependencies. Once we have them all, then we get on with the main definitions. So a sealer-unsealer pair creates a box. Here it's a map. I'm sorry, it creates a map that connects sealers to unsealers. So once we have the map, we create this channel called box. It's a new one. And then we set in the map, using the box as the key, this value. So now we have, we'll be using box as something that represents the encrypted value. If we hand someone box, they have no way of getting the value out except by interacting with this code. So here we put the value in and then return the box. So somebody can hand off this encrypted or signed value box, and the unsealer, when it retrieves it, pulls out this map from the map store with a peek. Says if it contains the box, then say, yep, this thing was decrypted or signature validated correctly. Otherwise you say, nope, I don't see it in there. And you return this sealer-unsealer pair that's that way encapsulates this idea of public-private key pair. Does anyone have questions about this part?
And the map is, because the map is internal, no one else can get the
Right.
reference.
Map store itself is inside this closure. No one else has access to it. The map never leaves. There's no way to get at the map using either sealer or unsealer. So it's all hidden. And yeah, it's just generating this box or one analogy I've sometimes used is a coat check, that you hand someone your coat and they give you back the ticket. And so then you can hand someone else the ticket and they can recover your coat.
Mike, can you maybe use this URL to open the same file? It will be highlighted. I put the link in the chat. Sorry for interruption. It's, if you scroll down, you will see. It's just easier
it uses syntax highlighting.
Yeah. Maybe it's just easier to look at the code. Yeah.
Okay. Next comes the deployer auth key. This is from Artur's design. Our original design for a vault was that it would wrap a purse. So a purse is a reference to an object that contains money. These references are, names or channels. And so because they're these unforgeable names, there's no way of getting at them from newly deployed code. So the idea of a vault was that it would be a wrapper that you would put the reference to in the registry, so any deployed code could get hold of it. But then the vault would check a signature to see whether to execute the sensitive methods on it. So if you wanted to withdraw money from the purse, that one would be checked by using cryptography. Artur's insight was every deployment we make is signed by the deployer. So if the deployer owns the vault, we can bootstrap that signature and not have to check it within the vault code. And so the deployer ID is something that is only accessible to the deployer. And the auth key derives an authentication token from the deployer ID in a way that gives evidence that this thing has been signed. In this case, it takes the public key bytes of the deployer ID and creates, using this from public key method, the appropriate thing. Now, if we look down here from public key, it uses these built-in rev address functions. So it's deriving from the public key a rev address and then using the auth key library to create a new authentication key from it.
So we can create multiple authentication keys from one rev address, from one private key.
Yes.
Public key.
And so then the resulting authentication key serves as the evidence to the vault that this thing is authorized, or that the requester is authorized to withdraw money from the vault. Here is the multisig rev vault main creation method. It takes public keys, those that are authorized to withdraw, as well as unsealers. So these are the people that are authorized to withdraw, and the unsealers are the contracts that are authorized to withdraw. And there's a quorum size that says we need at least K of these two groups in order to withdraw. So if the quorum size is bigger than both groups combined, or less than or equal to 0, that's not okay.
May I just ask why public keys are, and not authentication keys?
Actually, down here, we turn the public keys into authentication keys. It's just that a single party has to create the vault. And that single party should not have the authentication keys of the other parties, but only public information. So that the contract can be handed to unsealers by other contracts, but public keys are just data. And so it can only have public information going in at the creation call.
Makes sense, thanks.
Yeah.
So Mike, if I'm using this kind of in an application scenario where I use it for escrow between multiple parties, I guess the part you described about the quorum between public keys and unsealers, can you explain to me how that would work in case of an escrow, let's say, involving 2 or 3 parties?
Sure. How many of the parties are people and how many are contracts?
I was thinking escrow by itself is a contract and it might have 2 or 3 people involved, right? Something like that.
Sure.
Right?
Escrow itself is a contract. We're using the multisig vault to do escrow.
Right.
But the parties who are authorized to initiate withdrawals can be either people or other contracts.
Okay.
So it sounds like you were thinking of 3 people.
Yeah, well, basically, in the typical escrow scenario, you have, let's say, somebody like a bank as a middleman, and then you have the guy that's
yeah, 3 people seem, that's a straightforward thing.
Right.
You would put 3 public keys here, an empty list of unsealers here, and set the quorum size probably to 2.
Okay, I see.
If it's just 1, then anybody can use it. If it's 2, then you need at least 2 to do it. If it's 3, you need everybody in. And if anybody dies, then you're out of luck. So probably 2.
So basically, if I'm trying to eliminate the bank in the escrow scenario, we'll basically have 2 as a minimum. The 2 that are agreeing for basically the funds to move from here to there.
Yeah. But say you have some contract that governs how other contracts are able to use a vault, right? So these, here you would provide unsealers instead of public keys, and then you would need 2 out of 3 contracts to send their confirmations in to move it around. So if you're doing any automated movement of money using vaults, it's probably going to involve unsealers rather than public keys.
Okay, got that. Thank you.
Sure.
And this is the difference between normal revault and multisig revault. In normal revault, there is a direct relationship with public key, but with multisig revault, there is no relationship to like public key.
Right.
For this
so in a rev vault, the owner has a public key and that maps to a specific rev address. Here there are multiple owners, so you can't use a specific one of them to derive your rev address. And that's what we'll get to right here is instead of using a public key to get a rev address, we take it from an unforgeable name. So unf is a new unforgeable name, and then we derive the rev address from that. So the underlying rev vault uses this unforgeable key rather than a deployer auth key. Then we map over the public keys this function from public key, as we saw above, to derive auth keys and get the auth keys on the pub on this this channel. So here we're getting the auth key for the underlying rev vault, the auth keys from the public keys that were supplied, and the rev address from the unforgeable. When we have all of those, we create the vault at that address. If the creation fails, we say, here's the reason why it failed. We just pass through this pair. If it succeeds, then we return true with the with this multisig channel, which is where the methods are going to be on for the multisig vault. The rev address of the underlying wallet, underlying rev vault, so that you can check the balances on that and so on. And the rev vault itself. Since it was created using from unforgeable, and unforgeable thing is not exposed, and neither is the corresponding auth key, nobody can do anything with the rev vault other than call get balance on it. But it lets you work with, deposit directly into the rev vault. I'm sorry, there are two things. You can get balance and you can deposit directly into it. So this is useful for that purpose. Nonces. These keep track of the various requests for authorized actions. So each attempt to transfer money out of the vault uses a new nonce, because the basic design pattern is you call transfer and it returns you a nonce that you can then hand off to other parties that need to confirm that transfer, and they call confirm with that token to say this is the particular transaction I am confirming. So we start the nonce counter at 0. This pattern here of using a pair as the name lets us take a multisig vault and then parameterize it with respect to nonce store. So it's a way of deriving a new name from two other names that we have created. Here, this is a map from rev address and nonce to whether this particular transaction has completed yet or not. If it's true, then here are the people that have passed in. It's still active. Here are the people or contracts that have confirmed this transaction. If it's false, that means all of the needed confirmations have been received and this transaction is done. It's been completed. Here we expose the balance method. It simply passes it through to the underlying rev vault. Verify checks whether auth is in the list of auth pub keys. So here is auth. This is the list of, so this is an internal method, verify. You notice it's not on multisig. So this is an internal method. Given the index, well, this is a channel we're going to return the index of this thing on. And unsealed channel comes out here in the, right. So auth might be a public key or it might be an unsealer. And so if it's a public key, it'll come out on this channel. If it's an unsealer, it'll come out on that channel. So we call index of and check if it's in the public keys. And then we also check if it's in the list of unsealers. And this tests whether it's the
and we will receive results on both return channels.
Yeah, they may receive result on one or the other, and we'll see how it's used below.
Okay.
So this is initiating a transfer. You say, I want to transfer money out of this vault into the target rev address with this amount and this auth key, and then tell me about it on that return channel. So auth is either a deployer auth key or a sealed tuple that covers the particular multisig vault, where it's going, how much, and where to send the result. So this is essentially what the signature is over if you're using an unsealer. There are 3 different kinds of results. The first one is whether the call succeeded. If the call succeeded, there are 2 possibilities. One is you need more signatures, more confirmations. The other is if the quorum size was 1, just doing the transfer sufficed. So for example, you may have a multisig wallet where you want any of n people to be able to withdraw from it. You don't need multiple confirmations. So you set the quorum size to 1. When the quorum size is 1 and the transfer occurs, then it says, okay, that's good, it's happened. Otherwise, it returns false in an error message. So in here, we create these channels, pass it in, say, verify this authentication token, and then we read from both of these. The fold and the index of call will both return always, whether it's in there or not. Index auth pub keys greater than or equal to 0. So index of returns -1 if it's not there. Unsealed and info is a Boolean flag and which one it was. So it's saying, if we were able to use the unsealer on it and what we extracted from the signature was this stuff that matched what we got up here, then we can continue. Otherwise, down here, your authentication was invalid. So now that we have validated the authentication, we look at the nonce. So then we look up the nonce in the nonce store, and we look up the map of what confirmations are there. We increment the nonce store, so this is a new transfer request. If the quorum size is 1, then we're just going to execute it and be done. Otherwise, if there are more things to do, we're going to do this block down here. So if the quorum size is 1, then we set the value at that nonce to nil. We're not going to create a map to store confirmations because we only needed 1 and we've got that. In the rev vault, we execute the transfer for the appropriate amount. Then we get the success message back. If it succeeded, we return everything's good. We succeeded, there's nothing left to do, and we're done. Otherwise, we failed, and here's the message. On the other hand, in the usual case, when there are more than one signatory to the multisig vault, we take 2 cases. If it's an unsealer, if it's a contract that's doing the confirmation, record which one of those was used. So here is the which specific unsealer. So we create in the nonce map under nonce a pair that's target rev address, amount, and which unsealer confirmed it. Otherwise, if it's human, we store the same stuff, but the auth key itself. So we either store an auth key, an unsealer or an auth key. Either way, we're doing pretty much the same thing. And then we return success. There's still more to do, and here's the nonce to hand out to the other parties. Confirm does very much the same thing that transfer did in this quorum size 1 case. Well, actually, both of these cases. So if confirm is going to say, if the quorum size is, if we now have a quorum, then do this thing. Otherwise, if we still need other stuff to do, record the confirmation. So again, we verify the authentication token, we get the information. If we find that the unsealer worked or if the pub key is authorized, we grab the nonces. If there's nothing there, we say, hey, nobody initiated this transfer. You can't confirm a transfer that hasn't been created. Otherwise, we've got all this stuff, the nonce confirmers. If you're trying to confirm with data that doesn't match, like you call confirm with a different amount or to a different target, it says, nope, that doesn't match what we're expecting you to confirm. If you try to confirm twice, it complains. So if you haven't, if you've passed the right information and you haven't confirmed twice, if this is your first attempt, and this is the last one needed, then we do the transfer and return the message. Otherwise, again, we just store that you've confirmed it, either as you being an unsealer, a contract, or you being a person. If there's anything else stored in there, this is an internal error. We should never see this, but it's useful to tell someone about it instead of just leaving it hanging. And this part here is inserting all of that stuff under the name, under these, well, inserting it signed and multisig rev vault, bundled up so nobody else can intercept it into the registry. So anybody can pull multisig rev vault out of the registry and send to it, but they can't intercept messages meant for it. So it's a pretty straightforward contract, just lots of error handling, various cases to consider, but the ideas are all very straightforward. Anyone have questions about particular spots in the code?
So the transfer and confirm are essentially the same, right? Only
They're very much the same, yes.
The confirm additionally accepts nonce, right?
Yes, the transfer produces a nonce, the confirm expects a nonce as part of that. It also checks to see that the arguments passed to confirm match the initial arguments passed to transfer.
So I'm imagining that because in some situation maybe you don't know, who will be the first who will initiate the transfer, but you can easily try to make a transfer and you see if someone else already started, you can just confirm it.
Right. You can certainly try to initiate a transfer. Everybody gets that thing back. And then if you receive a confirmation request from someone else, you can abandon your transfer, right? Simply not handing out your confirmations prevents it. Not handing out the nonce prevents it from completing. So it'll pollute the map a little bit, but it won't cause any money to be withdrawn.
So we need to communicate the nonce between participants in multisig.
Yes,
transfer.
yes. That's typically the case.
Hello, Mike.
Hi.
I will have to do the same kind of multisig logic in some rholang code of mine. would you be able another day to help me a bit on some basic authentication in Rholang? Because I'm stuck at step 0. So I just need a bit of help for some issues I have.
So what do you mean by, I mean, would you like to do that now, or do you want to do that some other time?
No, not now.
I'm certainly happy to see what help I can give you.
Okay, so
Well, you had a problem with the deployer D, which is strange that you
yes.
are getting all the same.
So the semantics of the deployer ID, I am not particularly familiar with. I accepted Artur's explanation of how it worked, but I haven't dug into the code itself. If you're constantly getting the same deployer ID, no matter what deployer you use, that's a problem, clearly.
Yeah, that's strange because each time Rholang gets into a new deployer ID, I get the same deployer ID, which is the initial one and not the current one of the public key currently deploying. So
that sounds like a critical bug, and
maybe.
Sorry, I think that maybe you are misunderstanding each other. Raphael, do you, like you deployed a contract, which is some basic contract that is your game, for example, and you deployed it with one public key number 1, and then you are trying to use public key number 2 to call some methods inside this contract. Yes. And you get inside this contract public key, the deployer ID from the public key number 1, which is the deployer of the code, not the client of the code. Yes. I thought that this is the expected behavior.
Okay.
Mike, is this an expected behavior? The deployer ID is set when you deploy a code.
Right, so let me show you something in here. So these are deployer ID ops, right? But there's something that you can do that gets deployer ID. The way Rholang executes is when it sees new here, it replaces all of the references to these things with a concrete name. So the first time the code is deployed, any reference to deployer ID gets fixed and then never changes after that point. What is stored on chain is the deployer ID when the code was deployed.
Okay,
so there's no dynamic reference to deployer IDs.
Okay, so now I understand. Okay.
Yeah, so you have to sign stuff inside your client to provide justification that you can have access.
Okay, you have to do it with cryptography. Okay.
Yeah, so the original design for the Rev Vault involved using cryptography. We haven't removed any of those cryptographic methods, and you're still free to do things that way. It was just, this was a common pattern that a deployer wanted to regain access to code he had deployed before. And so Artur came up with that sort of bootstrap method. If it's different parties trying to access the code, then they will have different deployer IDs, and so you'll have to use cryptography.
Okay.
Raphael, you can see how this can be done in our chain status application. I will drop a link.
Yeah, so when you said you were always getting the same deployer ID, I thought you meant that the deployer ID that showed up on chain every time that you deployed was the same, and that would have been a bug.
Yeah, that was my understanding also.
Yeah. Any other
So,
questions?
Mike, Mike, I have one question. Going back to that escrow example, basically, any complicated scenarios for escrow would be done through the contracts, and the only control, so to speak, or precondition we have in the multisig is that somehow needs to, the result of all those contracts need to somehow boil down to the quorum size is how we control that. Is
But
that correct?
This multisig Rev Vault doesn't make use of any special privileges. Anyone can write a contract like this and deploy it, and it can wrap something like the Rev Vault. So anyone is free to write their own contracts that implement more complicated criteria
Correct.
for how to spend the money.
Right,
And
but
they
what
may
I'm saying is
choose-
when I write such contracts, basically the intersection of all those contracts has to give you a quorum size is how I would use this. Is
Well,
that correct?
if you are saying that your contracts are going to wrap one of these multisig Rev Vaults, then yes. But what I was saying was you don't have to use a multisig Rev Vault. You can write a my complicated fancy Rev Vault contract and implement your own criteria for how the money gets spent.
Okay.
Under what conditions.
Mm-hmm. All right. Yeah, that makes sense.
Mike, can you now say something about like view from object capabilities perspective? You know, what are the objects that you are giving? Like Nonces looks like something that you have some kind of capability that you handle. And
yes, okay, sure. So the first thing to point out is that the sealer-unsealer pair is an object capability pattern. The sealer is the capability to send messages, to sign them essentially, and the unsealer is the capability to verify them. So if you hand these to different parties, then they will have one possibility or the other. The next thing is that multisig Rev Vault is the capability to create new Rev Vaults of this kind. And only Rev Vaults of this kind are able to use these auth keys. So right here, this underscore multisig Rev Vault constrains the namespace of auth keys. So if somebody else creates, deploys this same code a second time, they will have a different kind of multisig Rev Vault. Then once we call this thing, what comes back is this multisig channel, right? It gets sent out, find or create, multisig, where did it? So here's new multisig. Oops. Come on. Find or create has to be the one that returns it. So here's create. And it does all this stuff.
It's after true.
Ah, here it is, right there. Yeah. Okay, so multisig is a capability to invoke the methods on this particular vault. And so that's where it gets sent back. RevEdder is a forgeable capability to get hold of the underlying rev vault. Rev vault is an unforgeable capability. It's the rev vault itself. So the rev address is only useful in combination with the rev adder service, right? So this is a forgeable thing that combined with some other service gets you access to this. Internally, this nonce store and this nonce map store, we never expose these, so no one has the capability to alter them directly. They can only change the state of this map by using the exposed methods. If you were in a language like C or C++ that aren't memory safe, you could use a void star pointer and start iterating through memory and looking at the resulting data structures to see if they matched what the format you expected this map to look like, and then go and poke things there and thus violate encapsulation, right? So C and C++ are not OCAP secure languages. In rholang, the only way you can modify those maps is by invoking the exposed methods on multisig. So you can reason about authority by looking at the lexical scope of particular objects that you're dealing with.
I have a question about when you say human, when you say it comes from a human or from a contract. In ArchChain, I guess every computation is called by a transaction. So finally, everything is triggered by humans. So I don't understand this distinction between.
Okay, so imagine that I have deployed a contract, and it says, if I get $100, I will donate it. Well, let's see, how would we want that to work? Here we go. If you submit a story for publication, then to my contract, that's kind of a contrived example. Contracts certainly get triggered by humans, but the effects of those contracts, what they do, may not use the authority of the human that is triggering it. So I could send something as simple as the message go to a contract, and then it would use its unsealer to confirm a particular transaction. Anybody could send that go signal. Say it's just waiting to receive 1,000 go signals, just as a measure of notoriety, just getting enough attention, right? So as soon as it gets 1,000 different go signals, then it executes its authority to confirm this transaction.
Okay, I see.
Yeah.
So
that has to do with something that object capabilities were invented to solve. So there's something called the confused deputy. And originally, when it was published back in the 70s, the idea was that people would use a mainframe with a C compiler on it. They didn't have their own computers to run compilers on, so they would pay for the time that they were using on the mainframe. So the question became, with whose authority should the compiler run? If it ran with the authority of some principal who had set up the system, then they wouldn't necessarily have access to the user's files who were, that needed to be compiled. On the other hand, if it ran with the user's authority, then the log file that kept track of how much computing time was used would either not be accessible to the user, to the compiler, or the user could specify the log file as the output file of the compiler. And so it would blow away the log file. No one would know who did it, and there would be no record of the use that the user had made of it, so they wouldn't have to pay. So this question of whose authority relies on the assumption that there are a bunch of principals, each of whom has their own authority. So one thing that I'm sort of uncomfortable with in Artur's design is it seems to be playing with this idea of deployer ID as authority of the deployer. If you store the deployer ID and hand it off to someone else, they have all the authority that the deployer does with respect to deployer ID. So it's a dangerous thing. That said, if it's used properly, it'll be okay. With object capabilities, instead of doing permission, which is kind of like a 0th level authority, what you have is in code the ability to change something. So if you imagine I am the only one on the file system that has access to a particular file, but I use my permission to that file. Using the same permission, I set up a proxy server that is open to the World Wide Web. Then anyone coming in on port 80 has the ability to change that file, even though I am the only one with permission to change the file. So that's the difference between permission and authority. Permission is identification of a principle, whereas authority is the ability to actually make a change. And most of the time, it's the authority that you care about. So if you're in rholang, what we're able to do is have successive layers of wrappers, and each wrapper can do logging and attribution and forwarding of messages to say, whose fault is this? If Alice gives some authority to Bob and Bob delegates it to Carol, Bob can do that by creating a wrapper that logs when Carol accessed it, and can put a different wrapper for Carol and Dave and Eve, so on. Each of those, you can track their access separately. Now, Alice will still hold Bob accountable for whatever Carol does, but Bob can at least say to Alice, hey, it was Carol who was abusing her access. I have now revoked Carol's access. Please don't revoke me and Dave and Eve. There's a story about a general who was annoyed at the IT department for making him change his password every 6 months. He said, it takes way too long to give my password to all of my subordinates who need it. The idea is people are going to delegate their authority whether they're supposed to or not. They have to do it to get their jobs done. What you need to do is create a system that allows them to delegate the least authority necessary to get the job done. And that's what object capabilities allow you to do. Confused deputies turn up in web scenarios with cross-site request forgery, XSRF. The idea is that if you use a cookie for authentication, that is, you make a request to a server and the server sends back some identifying information and your browser stores it locally, and sends that along with every future request, it will send it with every request to that server, no matter who started it. So if you go to a different website, a malicious one, and it does a cross-site post using a form, it can't see the result of that, but it knows that the cookie will be sent along with it. So if you've got a blog and the delete my blog URL is predictable, and you're only authenticated using the cookie, then a malicious site can make the form request over to the delete my blog button, and your browser happily sends along the authentication information with it. Now, the workaround that browsers have come up with was to reinvent capabilities. On each web page, they send a cross-site request forgery token that has to be echoed back. So when you get the web page, they are issuing a fresh capability to delete the blog. And they know that because you are the only one who can see that, and nobody else can predict it, you are the only one that has the authority to delete the blog. So despite trying their hardest to use permission-based systems, they had to reinvent capabilities in order to be secure.
Which complicates things a lot.
Yes.
And this is exactly the purpose of this out token that you are sending, right? And
yes,
you have some internal information.
Yes, the auth token is a capability to initiate transfers and to do confirmations. So that's why instead of using the deployer ID directly, it has this deployer auth key, where from your super powerful deployer ID, you derive a less powerful auth key that is used in here. So you should be very careful not to hand off this deployer ID to contracts you don't trust. But this lets you reduce the power of the deployer ID to something that is only useful on this particular vault, or this particular kind of vault, the multisig red vault.
But you said there is crypto stuff already present in rholang, and we can use it without relying on deployer.
Yes, if you wanted to write your own wrapper for red vaults, you could do it without using auth keys at all. You could just use public keys and the signature algorithms like SecP256K1. Great. Any other questions?
I have one question. I mean, I don't know, it may be slightly off topic, but let me ask anyways. So there was this conversation that came up about once we're in mainnet, and let's say somebody like Raphael deploys his DApp, and then there may be two situations. Either a user may be using it and or another DApp developer may be using it. And the question was, how would the rewards be distributed? And Greg's answer was, oh, they would go to the DApp developer. But keep in mind that we have
what rewards?
Well, no, not validated rewards, but I guess some portion of the payment. Now, members that use the network are supposed to get whatever 10 or 20% back, right? That's how the co-op is set up.
I have no idea how the proof of stake contract is handing out funds. The only stuff I've seen in the proof of stake contract is for validators. If DApp developers want to get money, they should charge money as part of their API that they expose to their clients, right? hand me the reference to a purse with enough rev, and I'll execute some code for you.
Right, but this particular thing that I'm talking about is about member rebates, like how the co-op is structured.
With member rebates, I have no idea. I haven't
Okay.
seen any code for that, so I don't think it's been implemented yet.
Yeah, because I don't think it is. That's I mean, what the reason I'm bringing it up is I'm wondering if there's a way the multisig vault could be used as a part of the answer to that. And the question is
signatories.
Well, that's the question. I mean, because Greg was saying that well, you know, the member rebates would go to the DApp developer because they are the ones.
You can certainly set up a contract that, you know, how about this? The R-Chain cooperative can set up a contract and go through some kind of paper registration of the DApp developers and say, okay, now we have added you to this contract that you will get some portion of the funds that are put into the co-op wallet, and have the contract have an unsealer, a sealer-unsealer pair, and the unsealer is part of the red vault. And so the contract can trigger every time there are validator rewards that go to the, you know, some portion of the validator rewards go to the cooperative. This thing can also pay out of the cooperative purse to the individual DApp developers automatically.
Mm-hmm.
But none of that code has been written yet, and it's not even clear to me that there's code to put money into the cooperative's vault yet. The only code I've seen is stuff that delivers validator rewards directly to the validators.
Yeah, that's correct. I mean, basically all slashing has to go to cooperative wallets at this point in time, and perhaps more.
Right. Tomislav, aren't you working on that change? And at the moment, it's just being set to 0 instead of going to the cooperative?
Yeah, it's just set to 0. I think Isaac will do some changes about that. But
okay.
For now, we don't really know exactly we don't have information about a cooperative wallet. That's
yeah. So all of that is yet to be determined.
Right. I mean, basically, we need to create a cooperative wallet or one or more, and then we have to send the slashing rewards to it. And then there is all this other stuff about member rewards and discounts that the members are supposed to receive for using the network. And the concern on the member rewards end, I guess, is to say, essentially a DApp developer may have some users that are members and some that are not members. And somehow, I assume the ones that are members should be receiving some rebate back. Is kind of what that's the piece.
Is there a distinction between the fees you're paying, like for gas to actually run compute on the network, versus like the fees that I'm paying to use a DApp just because the DApp dev said it costs money to call this thing? Or is the member discount?
Yes, those are very different. The fees that you pay are part of the deployment itself. Any charges the DApp author or the DApp itself requires are written into the code of the DApp. So it would expect to receive a purse as part of the API.
Right, that makes sense. So Rao, I guess like in the context of your question, are you expecting members to get discounts on both or only on the gas fees?
The only way that the network could enforce is through the gas fees. That some portion of the fees ends up going to the cooperative vault.
Yeah, okay, right, makes sense.
As I understand what Greg was describing, that, you know, clearly the user of the app would pay the gas fee. But in terms of at the end of the year computing the rebate for members, that amount of usage would be attributed to the deployer of the contract.
Let me see if I understand correctly what you're saying. So what you're saying is the quote unquote member rewards or member discount, I should say, is going back to the deployer, the dApp developer or deployer, is what you're saying.
That was what I understood from what he said.
I think he's trying
totally
to.
wrong.
I think he's trying to stimulate dApp development by saying the more people that use your dApp, the more rewards you'll get. But it can't be an automatic thing because that is far too easy to game. I can set up a simple contract that simply does nothing and then send a bazillion empty messages to it, right? And that has an enormous signal in checking.
Right, but the user would have to pay the gas.
Sure,
right?
They'd have to pay some gas, but I mean, if you are sending virtually empty messages, right, then it's going to be a very small deployment to get a whole lot of activity to get a much bigger piece of the refund. I don't know if it's worth that, but it can be gamed easily enough that there has to be a human involved to approve the dApps that are going to be refunded if there's any kind of program like that.
You don't want incentives for inefficiencies.
But also to what Jim was suggesting, or Jim's interpretation of what Greg was saying, I don't think the membership agreement allows that interpretation. Membership agreement says the members will get the rebates, not that the co-op redirects those rebates to dApp developers. Those are two different things. I think if the co-op wants to reward dApp developers in some way, we have to figure that out separately, because I don't think the current member agreement says anything about that.
Yeah, and it's simply technologically easier for the dApp developer to say, hand me a purse with enough rev in it, right? They get to set what they want their reward to be.
Yeah. So in terms of
takeover.
In terms of using this as a front end or using some kind of wallet, like say, what's the most elegant way, I guess I'm wondering, for a dApp developer to use either the multisig wallet or some other mechanism so that the user can do what they need to do with the system, with the gas and everything, as well as hand over a piece of whatever they agree to the dApp developer. Does it have to be a multisig wallet, or does that not have to be? I guess it could be two different paths without actually confusing the two. Because I'm thinking basically the dApp developer has to charge the user for the cost of the deployment plus whatever profit they want on top, right?
Yeah, the deployment itself is a one-time thing, so you could amortize that over the lifetime of the dApp. The user is paying the gas to execute the dApp, but the dApp developer is free to say, I think this is a valuable enough dApp that I want to get paid a little bit for every usage.
Mm-hmm.
Right?
Yeah.
So that would be an extra parameter on the API where they have to split a purse off, where the client has their own rev purse. They have to split off a purse and pass it to the dApp in order to pay the developer for his time.
Okay, so basically the gas would be a pass-through potentially, and then the whatever the dApp developer collects from the user is going to be their keep or profit or whatever it is.
the gas goes to the validators. The purse that's part of the DApp API goes to the DApp developer.
Okay.
What if the DApp developer wanted to sponsor the gas for running the app?
In that case, you would need a separate service to monitor. And so the client would send a message to something that basically just logs that the client sent this thing. Then the off-chain service would monitor that, see that the client had done that, and then pay for the actual deployment the client wanted to invoke. So it would have to be a two-step thing. At the moment, I mean,
Are we losing Mike?
we had lots of took player
we can have some contract that can create tokens, right? So
yeah, that's make mint.
yeah, okay.
So this is in the resources directory right here, make mint. You can get it out of the registry, but this creates a new token and you can use that for whatever you'd like.
Okay.
You can also wrap these purses in vaults, like you could make a multisig my token vault. Yeah.
Yeah. This seems like very similar to this ERC 1155. This is just improved ERC 20.
Yes.
Cool. And maybe this can be a way to charge for your DApp, because you can distribute your token and say, supply some amount of this my tokens to my account.
Yes, that's totally true. And if your token is a utility token, then perhaps you can list it on an exchange, and or maybe someone will build a distributed exchange. And
is it this contract make mint? Can the tokens represent unique items?
This has a balance rather than tracking unique items, but you can use this as a blueprint for creating a different kind of token that would track unique items.
Okay.
The thing with purses is that they are independent objects. So in Ethereum, you have a big table that tells what every account's balance is. Whereas these are independent objects, and it's just invariants of the code that preserve the total money supply. So it's a different approach than what was done with Ethereum. Rev vaults are much more similar to Ethereum, right? There's a big map that has a rev address to a vault. That's not the case when you're doing a generic purse with a mint. But I mean, just saying new blah will give you a fresh thing that has never been seen before. And if you store that thing in a map with what it's supposed to represent, that suffices as a token tracking system.
Now with the ERC 1155, if I have the correct, is it called the purse? Whatever, you can put any kind of token in there or anything in it. Whereas I guess here we're talking about purses specific to a currency.
So I have no idea what 1155 is. If there's a specific thing you would like to do, I can talk about how I would do that in rholang.
Well, the 1155 basically just combines fungible and non-fungible tokens. So that a token can be of any kind, I guess. So they want to put an asset. You can represent any kind of asset, and you can put it in. You can trade them.
For example, in one contract, you would have 1,000 gold and some unique cards.
Okay, so
like
in Ethereum, there's this concept of accounts, right? Contracts, each contract has its own account. It's how they're funded and what they can spend. And individual users with public keys have accounts. There's no such concept as a contract having an account in rholang. There's not even a person having an account. There's a sort of rev address idea, but that's not connected to any particular account or person. It's just a number that you can look up a vault with. So if you want to store stuff, all you need is in rholang is a map. And then you expose a method that says, what do you want me to store? And it takes whatever gets sent and sticks it in the map. If you send it a purse of one kind or another, they're all there in the map. If you want to put restrictions on what kinds of things you're sending, like they all have to be purses of some kind, you can also check that they implement the right API, right? You test out what they do, and but that's, I guess that's something that reflection could provide, but you'd have to kind of work on how to make that happen. Reflection is when you're passing a code block itself, but if all you get is a name, you can't see what's behind the name. So it might be worth coming up with a rholang standard to say, here are the APIs that I'm advertising, like some gRPC kind of thing between services that are running. I guess RPC, G is Google's.
Thanks. Yeah, the blockchain art, we're looking at, how we can do a prototype, and looking at how Ethereum is handling that now. And
yeah, there are some general features of the two systems that are similar, but you can't lean too hard on how things are done in Ethereum because they're just very different in our chain.
yeah.
But we can share the data, like hash of this artwork, and it will be stored a little differently, but we can have the same behavior, right?
Oh, so you're trying to track physical objects using this thing and track who owns them?
Yeah, and this is something that Eric talks about blockchain art. That
more digital objects.
Yeah, both digital and
okay.
physical art.
And he talks about ability to for the author to to be able to control you know, transactions in the future, and maybe to have some veto on some transaction and this kind of stuff. I mean,
Yeah, I'm not sure how DRM would work on chain. Data itself is necessarily selfless. There's no identity to data. You can create unforgeable names, right? And those have a unique identity that can be passed around.
So identity, in this
But
case,
as far
identity
as-
is the hash of this artwork.
Right, but it's just data. How do you prevent the artwork from being copied? Right? How do you prevent copies from being made with and passed around without paying the artist?
That
So
gets
you will know
into
the hash. So
there's some intricacies with blockchain art that is specific to that domain, and that would be a conversation with Eric to understand that. It's almost as if you had two copies of the same piece of art, you know, and they were identified, you know, had an ID with them, but one was illegitimate and the other one was
Oh, I see.
acquired
So it's sort of
proper.
like a signed baseball card. Because it's hard to, in this case, it's, you know, really impossible to forge the signature. But, you know, if you have a signed piece of art, that's different than, yeah, okay.
Right, that
fair.
provenance that has, you know, it's gone through the proper channels and created that way. So the author creator gives it that piece value, as opposed to if something is just copied, the author does not give value to that. And in the art world, that's acceptable.
Right, and you know, there can be a one-time key to retrieve it. Of course, that's off-chain, but
yeah, you can, you know, buy a print, as it were, right? An authorized print.
Not exactly.
yeah. Now,
okay, so insofar as people are willing to pay, you know, fake internet money for fake internet art,
well, who knows what the possibilities are? Yeah. Good. And I wanted to mention, if Raphael and Mike, if you guys do decide to get together at some point to help, if Raphael has any additional questions, we have on Tuesdays a DApp developer working group. So you're more than welcome to get together at that time at the DApp developer group, and you know, we can record it and share whatever is discussed with everyone in the community. And the DApp developer group meets, it's 3 p.m. Eastern Standard Time, which is 12 p.m. Pacific Time. So.
And UTC?
Someone's going to have to help me with that one.
I guess 5 p.m. UTC.
8 p.m. UTC.
Okay. Yeah.
Mike, I sent you our community calendar. So
yes.
Cool.
So
it should
basically, I had my question. I had a question about authentication. I wondered if I could do it without requiring the client to sign a message, but it seems like I have to require to use cryptography. So that was the thing I wanted to.
Well, it depends, right? Because you can still get an auth key. It's just that you have to track the client's auth keys as well as the DApp deployer's auth keys.
No, but I guess the simplest solution is the I will copy some bunch of rholang code from the Joshi repository.
Okay, great. Well, thanks for your time. Hope I was helpful.
Yeah, thank you, Mike.
Yep, thanks.
Thanks for joining and presenting, Mike.
Thanks, Mike. This was good.
Great. See you all later.
Yeah, thank
Have
you.
a great day.
Yeah,
Bye
thanks.
bye.
So, all of a sudden, I'm a little bit confused as to the difference between an auth key and a one-time token. I guess they're not the same. Yeah. I'm gonna have to go through this video again to get straight on how the auth.
Yeah, we can. Yeah, we can play with the different solutions and see, you know, how they are differ, and you know how we can use it. And what I would also like to say is we had conversation, you know, how to get data from the blockchain, and so we are now like developing the whole solution, but there is like existing idea how to do it. So we'll have option to when you are running read-only node to create a deploy on this read-only node, right? And this deploy will be rolled back immediately. So in that case, you know, you can do whatever you want on your instance of Arnold, and you don't have to pay anything for this deploy. And you know, when you are able to do this, you can get any data that you want. You can do you know, you can get something from registry, or you know, whatever.
And it does not roll back the blocks like the listen data name API, right? It's a direct rholang execution.
Yeah. This deploy should be like the same as you are now doing for that you are giving the validator. But this is not the real deploy. It will not go to the network or anything else. It will just be for you to you know, to get the data from some name registry, or you know, and then we are looking maybe this will not be immediately available, but if you can deploy a forgeable name, you know, so if you can have API that doesn't accept just rholang as a string, but something similar as now listen for data at name, that you can supply rholang, you know, abstract syntax tree, then you can specify some unforgeable private name, and you can get some data back, you know, in the same way as deploy, right?
Yes,
so,
because if an unforgeable name is not exposed to the registry, we cannot read its value from a blockchain deployment.
Exactly.
Okay.
Exactly.
Yeah, I see.
But if you can specify it, you know, not as a string, but you know, as a construct of rholang code, and if you know Arnold accept this as a valid deploy, then you can get the data from the private name.
So, you know, how is that different from the way that it was working through August, where you could do an eval and you didn't have to do any deploy? You could access values, you could access the registry,
so this is not related to this problem. The problem with registry is probably that all the existing system deploys or standard deploys are not included in evaluated you know, mode. And registry in one moment is transferred to rholang code from Scala, and probably, you know, because these deploys are not included, you know, it stopped working. So Mike is looking at this, so yeah, it should work. Yeah, and also one step in the future is also to expose, and Mike confirmed this, and I'm super happy for that. We will have this API exposed in the rholang, in the interpreter, in algorithm. So we will be able to communicate or deploy this, like temporary deploy from the rholang code directly. So you'll be able to operate with the blockchain from the rholang code directly. So this is great, and then you can take the data also.
Yes, for get balance, it should work with no problem. But effectively, to get value of unforgeables that are not exposed, this would require some additional logic. But okay, that's great news.
Yep.
Very great news. I'm trying to find this because the Ethereum JSON RPC API has this capability, and it has a name. I'm trying to find it. I think it was something like Ghost Deploy, or I can't remember because I used it very long time ago.
Yeah, maybe we can use a similar terminology in that sense.
Yeah, I think it could be cool to find a name to refer
so
to.
Rafael, if you have some information or idea, you can post this on in our dev Discord. We have off-chain data channel, so yeah, I'm collecting all the information that we need, and yeah. So, and also now, what can we do on the with the validators, right? We have still the problem, how can you get the data directly from the validator? So we will need to create some kind of normal wrapper around this API, right? Because you are getting the data and you are creating this deploy, which is completely free. So this API cannot be opened completely, right? Because you can abuse it, and so
yes, but I think it's the same for listen data name, which can be blocked by a node, and it does not get it out of the consensus. So basically, a node is not required to run second levels API like listen data name and stuff like that.
Yeah, but completely blocked this kind of API, to get the data. Maybe it's not, the solution that we want. Maybe we want to have some kind of authentication, some application with authentication in front, where we can say, oh, all the members can, easily access without running their own read-only node. Right? This makes sense because,
for example, I think on Ethereum, every basic node, I don't know if they implement the JSON RPC because it costs some resource. So I think they're all just running the first level of blockchain protocol, and then you have to rely on third services like Infura to perform some additional extended API jobs. And on our chain, it might end up the same way because running a node is costly. So I guess people won't bother exposing some fancy APIs that consume. So yes, that's a very interesting topic. And basically, okay. So that's heading to the right direction.
Yeah. So we can discuss how can we create as a community something that we can use for our purpose. Yeah.
Basically, every node of this is why this is related to my project, because a node of DAPI is not just a node of the blockchain. It also exposes some APIs like the one you are talking to. So the DAPI network is kind of a distributed infura.io on our chain. It will be that kind of thing, because clients of DAPI will have to do some ghost deployments to get some data, and they will require the DAPI node to perform this task. And the interesting thing is that the DAPI network members will have additional revenues by exposing such APIs, simply because they will benefit through domain name purchases from user. They will be compensated by for the additional work that is outside of blockchain consensus.
Yeah, this makes sense. Yeah.
But basically, yes, it's it can. Let's see how it goes.
Yeah.
Because, for example, for balances, it's such a basic information that if I was able to technically compile the R-node source code, I would have tried to hack the wallet, the wallet compute, and to send it to some external database. This way, we could get one's balance in 1 millisecond. It would cost quasi nothing.
Yeah, this is another thing. How to expose all the transactions. So maybe the first option that we will now have is storing all the transactions directly on the blockchain. So for example, you can create your Revolt and supply additionally some name where all the logs will be sent, and you can collect everything, and you will have the balance. Of course, this is like duplicating all the stuff that you already have in the blocks, but it will be easier accessible. You will create this ghost deploy. You can get all the transactions, and you can display it. But this is not like an optimal solution. So, but for start, I think we will have this kind of stuff. And you can also delete this log and release the.
Yeah. Well, in Ethereum, they don't bother to put it on the blockchain because every node has the same logs, basically. And if the difference is that they have a log that's trustworthy. What contract is saying what thing. It's not just a log of everything that people put the standard out. So if we had identifiable events and transaction log capability, which I guess we would build into the contract, the purse contract to generate events when there's a transfer.
Yeah, maybe our node could output another log file which logs everything that happens which is rev related. So every balance changes is logged, and this way any third-party application like a database or any other program running on the same OS could read from it and build any kind of other application based on the balances and the transfer that occur.
Yes, this is really the idea to expose API that we already have inside the node to rolling code that you can evaluate a rolling contract which will receives events for your addresses that you are interested in, and
Yes.
then you can call any other external application database and whatever you want, and store it and do whatever you want.
Yes, but for example, the mainnet has been launched, so I have been running a node for 1 month, and I want to get the entire history of a given address. So will it be possible with the thing you are describing?
I mean, this is you can already do this with a reporting API, more specifically trace API. You can trace the whole execution, but the API is not very easy to use because you are getting all the rolling code, and you need to parse a rolling code as which is executed. So
yes, but it is real time. So how can I know about stuff that happened 2 weeks ago?
So this is something that you can explore the whole execution, completely in the past.
Okay.
But we can do much better, right? You can query, but you can also have it real time. If you can directly call, you can query the blocks, and you can say, oh, I'm interested in this specific name, and we will expose this API to the rolling, which is not on the blockchain. So you can, very easily manipulate rolling code because you are writing rolling, and you will be able to connect to external applications. So you can just stream or whatever you want to this external application. And I would like to see this whole thing, more inside the rolling, because it's much easier to use it because you're working with rolling code. So we will have necessary stuff for mainnet, and after that we will create more nice versions, and yeah.
Great.
Yeah, this is definitely good news. And we will have a checking balance then for free, right? Which is absolutely necessary.
This is the killer feature of ArtChain, free get balance.
Yeah, man, I'm what I would like to for the mainnet that we have is directly controlling a wallet from the REPL, So you can just evaluate some code. You will create your own like storage for your private keys and whatnot, and then you can just go to Arnode REPL, and you can say, oh, here is my contract from transaction, and I'm creating a transaction from this rev address to this rev address, completely inside the rolling without, you don't have to trust any other code than just your read-only node. That would be nice. Yeah.
So Tomislav, what state would the read-only node have access to? Would it be like the latest like finalized state or something along those lines?
Yeah, this is a good question. I'm thinking that for this ghost deploy, you should be able to, this API should give you a really nice, way to specify from which point in the history you want to, put your deploy. Because as you said, probably in the most of the times you will want to create a deploy just after finalized block, right?
Yeah.
So you can say, oh, anything that I can get from this from my deploy, that this ghost deploy, it is the real data because it's built on the finalized block.
Right.
Yeah.
Right.
But it would be nice that you can just specify the block hash and say, oh, give me from this point, and just so we can probe, different forks with the history, just explore and see data that you can.
Oh yeah, that would be really cool. That reminds me of Git a little bit.
Yeah.
I
I was
was
not expecting that we will have this.
I was thinking that a GraphQL interface could be used to traverse it. That's the first approximation. We probably want an R GraphQL that extends GraphQL.
I mean, we have rholang, right? So
we have rholang, right? Rholang.
We can directly do it in rholang, and we just need this block API inside the rholang. Yeah.
Right. Yeah, which is similar to.
Yeah. And then we can, if we have the protocol like HTTP inside the rholang, then we can create GraphQL interface inside the rholang, right? Because this is what the GraphQL is, proposing. Build your GraphQL server in your language. So we will create a GraphQL server in our language. And, So yeah, I'm happy that Mike confirmed that this is something that we should do. So
yeah, this is very interesting because right now I can ask any node for the value of an unforgeable name 2 weeks ago, for example. I just have to give a depth of 8. But what with the ghost deploy behavior, I can execute some rholang logic 2 weeks ago and see the result. Yeah, so that's very cool.
Yeah, and for start, maybe we will just have a way to get something from the registry without specifying private name. But this is also fine because you will register your DAPI application directly in the registry with this unforgeable name, and then you will just with this ghost deploy, you will just read the data from the registry. And that's it. And now you're only interested in which point you are creating this ghost deploy. If this is on the finalized block, this is the last value.
Yeah. Okay. Yeah. Basically, DAPI application it's very, very simple. It's just a big string stored in the registry.
Okay. And you will be able to step by step move most of the code of DAPI to rholang, right? So you can say, oh, my DAPI application is really application on the blockchain. My rholang code is you can see it on the blockchain. It's I have a proof that is doing what I'm saying is doing.
Yeah. But okay, so right now, when you deploy a DAPI application, it is identified by its unforgeable name ID, which is the 64 characters hexadecimal. So okay, so you're saying that it might change and it might be easier to identify some resource on the blockchain by its registry address instead of unforgeable name.
Yeah, you can reuse registry for your purpose without creating your own mechanism because it's already there. So
okay.
And the registry is updated. This is also something that I was thinking that if we have time to ask Mike, I think Rao mentioned this somewhere, but I don't remember where. We're now using this 3-hash map for the registry, which is much nicer than one big map that was used before, like normal rholang map. This is like a special map that it uses tree and hashing to separate different branches. So you can update this map without loading everything and saving it. So and sorry.
It's the same thing as Redux logic with the Redux store on the front end.
Yeah, exactly. Something very similar. Yeah, and we can explore this in our sessions maybe to see how can we use it, because I think it's useful to see this like patterns in rholang, how to do this stuff, as Mike showed us, sealer, unsealer, because these constructs you need it in lots of places. So it's useful that we know how to work with them. And I was using the same 3-hash map for POS fix for merging. So that was great, because I was trying to do like to solve this problem with my own solution, and when Mike showed me that he already had like complete implementation, I was just use that instead, and it was much easier.
What were we even using the tree hash map for before we used it in the POS contract? Because it's been there like the whole time.
Yeah.
So what's the point to update the registry map to a tree hash map, and like it just hadn't been done?
Yeah. I mean, Mike done it in few hours. I mean, it's
yeah. All right.
So Mike didn't know that we are using just like simple map inside the registry. So
yeah. Clearly not.
And this is really this is example why it's important to know these structures that you already have, these patterns.
Yeah, absolutely.
And we can maybe use some of this stuff for ERC, like rolling version of ERC 1155.
One question I wanted to ask is so the ghost node API that you've been talking about, like this work is not going to be done on that before the launch of mainnet, right? Like we
will try to do it. So
before mainnet.
I'm starting on this. I already started, so yeah.
Oh yeah, great. Okay, cool.
Because I used listen for data at name to crash all the testnet, all the nodes in the testnet. Just to show that this API is not great.
Yeah. So I started paying attention after listen for data at name became an issue, and don't 100% understand what listen for data at name does. Can you like explain that briefly?
Yeah. So the problem was you're supplying, you want to get data from the private name.
Yeah.
Private unforgeable or like deployer D but it's private names. This data for this name is somewhere in the blocks.
Sure.
And this method on API was just traversing this method accepting the depth parameter. How many blocks in the past you want to get the data. And its implementation was very simple. Load all the blocks that you specify for the depth. So if you want to know, for as much as possible in the past, you will supply the maximum number.
Yeah.
Which means load load all the blocks.
Yeah.
All the blocks. And then go by each block and try to find if this name is somewhere in the event log. Is it produce, consume, or com event?
Okay.
And because I seen the code and I knew that node will load all the blocks, I was just supplying a bunch of requests to the node. And I gave him a name that doesn't exist. I thought, but node will load all the blocks. And like 100 requests was enough to kill the node in 15 minutes.
Oh. Wow.
Yeah.
And so something like that is you wouldn't have to pay for. Like I guess that was the original.
Yeah, it's totally
idea.
without.
Okay.
It's just normal methods and without any cost. You can just execute without deploying anything. I was just I created this 100 requests for each of the validator from my PC. I didn't use all the TCP connections, so it was really easy to just attack it and kill it.
Yeah. Wow, and it shut down the network in just requesting this listen for data at name?
Yeah, because nodes load, each request will load all the blocks. Each request.
Yeah.
So we didn't have any cache also. So, node will just eats all the memory and it'll just crash. And that is my point, just.
Yeah. Oh, okay. Yeah, that's no good.
Yeah.
Well, this is all very interesting. I'm curious to know, have any of you had any thoughts about Greg's talk on Monday, New Year's Eve? The Casper talk where he talked about the phanoplanes.
I'm definitely interested in that, but I didn't have time to, explore it. But I was listening some of your YouTube videos that you are posted. So,
oh yeah,
thanks for that. Yeah.
Do they help?
Yeah. I mean, for me, this is like an introduction that I need to, first, understand. And yeah.
Cool. Yeah, the ones I've shared really resonated with me, and I think there's a couple of groups of people, one of whom I think may be a crackpot, that Wild Trig. I don't know if you've seen that one, but I mean, he's got some interesting slides in that presentation. I shared the one of them where he talks about the what is
this
it?
one guy in front of whiteboard, right?
Yeah.
Yeah.
This,
Geometry is
okay.
about formulas, right?
Yeah. Exactly. Where he talks about that triple quad, the triple quad formula, which is supposedly a more important axiom than the Pythagorean theorem. And so, according to him, it should be as obvious, but I mean, it's very interesting, I must say.
Yeah.
But then,
I mean, just looking at, I don't understand, like, okay, so what are the Q's in this triple quad formula? Because you have the screenshot from the video where you can actually see what that formula is.
yeah, the Q's are the squares of the A's and B's and C's.
Okay, being like the different sides of the side lengths of a triangle.
Yeah. The parallelogram formed is called the quad.
Yeah, well, I mean, I'm pretty highly suspect of this formula considering he's squaring a sum on the left side and then he's doing the sum of squares on the right side. And the only way that this is, and there's a factor of 2 in there. The only way this is true is if all those quantities are 0. So I don't really know.
Well, he said it's an if and only if statement. If and only if.
Yeah. Well, that's what I'm saying.
The if and only if points lie on the same line. So.
Well, unless I don't understand what the Q's are, but I'm saying that formula is true if and only if all of the Q's are 0. Because he has like the square of the sum of Q1 plus Q2 plus Q3. Like, okay, we can expand that sum. It's fine. I mean, it's the sum of the squares plus 2 times the product of all of like the distinct pairs, essentially. But on the right side, he's only got the 2 times the square. So, oh no, actually, I have to think about it a little bit more.
Yeah, it's confounding to say the least. I've been round and round with it.
I've never heard of it. I'll say that much.
Had you ever heard of the Erlangen program?
Yeah, I've definitely heard of Erlangen program.
Did you understand it?
You know, it's been a really long time since I've thought about it.
I'll be honest. I was telling Jim this morning, I never understood anything about it until now. And now it's.
Oh, really? Okay. Sure.
With what Greg's been talking about in these different geometries, that we can now look for, we can look for their signatures in somehow in our machine. I'm not sure what the implications of that is, but all of a sudden, his talk kind of opened up that whole idea of finite geometries and non-Euclidean geometries.
Oh yeah, I mean, I've been thinking about non-Euclidean geometries for a really long time, but that's probably why I've heard of this Erlangen program. I thought, oh, I'm forgetting his name now. It doesn't really matter so much.
Who are you thinking of? What do you know?
A mathematician. I can't remember his name. I'll think of it and then I'll put it in Discord or something later on. Grothendieck. That's the one I was thinking of. I thought he was. I thought he was connected to this Erlangen program, but I don't see his name mentioned in here. Yeah, so I had like this faint feeling that there was some kind of connection between geometry and group theory. That's essentially what it's saying. It's just like characterizing geometries with group theory and projective geometry.
And can you say something about relation to algebraic approach? Because this is something that this guy was talking about, like.
I mean, group theory is algebra, right? Group theory is like it's like a canonical form of algebra, basically. It's like algebra with like minimal laws, essentially, because any algebraic structure is also a group if you just like forget about some of the operations. But I don't know if that's what.
Why group? Why group? I mean.
Yeah.
A group is like monoid with inverse, right?
Yeah.
With what? I didn't hear that.
With inverse.
Inverse. So groups, because typically you're talking about symmetries in geometry, and so like you always have a group of symmetries that you can talk about.
Oh, this is why I want to have inverse, because you want to have these symmetries. Okay.
Yeah, because like, I mean, something like a reflection is self-inverse essentially, right? Or like rotation, you can always rotate in the opposite direction. So you always have this inverse when you have a symmetry.
Oh yeah.
Yeah.
And the projective geometry, I was reading about this, how it's called, Erlang program. And now I see projective geometry as like more general than all the other geometries, right?
Well, what it is it's constructionist. We can always, these generative geometries are constructible realities. They, if we consider that everything there is has been constructed, this is a good way of creating, of how geometry emerges.
And projective geometry has the least constraints in that sense, right? Affine geometry
Yeah,
is
yeah. I think
somehow.
the parallel postulate is considered a rather big constraint,
Yeah,
and
yeah, yeah.
so projective geometry does not have the parallel postulate.
And affine geometry also, or?
Yeah, yeah,
Yeah, affine geometry has the parallel postulate.
Yes, okay, okay.
Yeah. And affine comes from affinos, which means affinity comes from the word affinity rather than finite, which was my first intuition, that it was affine came from finite geometry, but it comes from similar or affinity for. What are the implications of that? But
There is affine types, but I'm not sure if they're related.
yeah. Well, when you have a projection of one geometry into another, you basically just have what you had already. But when you have a generative geometry, it has a form that is becoming.
When you say generative geometry, you're assuming this is projective geometry, right? Or
Yeah, I mean we find the symmetries, but not. But they're emergent. I don't know what.
well, I can see why. I mean, I can see that this idea of Greg's has certainly made me think. It's made me think a little bit, and I suspect it has others. What questions would you ask of Greg now that you've had time to think about the video? I'm wanting to know a little bit more about. He did qualify his statements by saying that it doesn't have that much to do with the blockchain or with our chain. But nonetheless, I'm the fact that he presented it where he presented it, makes me want to ask. I mean, I guess that would be my question. Why give us those that particular intuition right now?
well, I was thinking that he wants to emphasize this like interaction approach, right? He was saying that interaction and like it's not in a functional style, right? Because in interaction is more expressive than set based, like in functions between.
Yeah, I remember him. I need to watch the Casper video one more time, or maybe I'll read over the transcript again. Every time I read the transcript, I make some corrections to the.
I'm reading one paper about interaction, and it's really nice. Let me find out. I think he mentioned these Abramsky interaction categories and foundational type concurrent programming, but yeah, this one. Why interaction is more powerful than algorithms? Let me find somewhere.
who are these people writing this paper?
Who are the authors? This is Peter Wagner. Yeah, this is the one. I will put it in the Discord. I didn't read the whole thing, but it says that you can express much more than with the functions.
Where did you put the link?
In the Colab Discord computational calculus channel.
Okay. Okay.
And the format, it's not completely standard. You have some kind of spiders in the pages, and yeah, this is, for example, interesting.
Milner wrote
this
a paper
diagram.
on. Milner wrote a paper on interaction.
This one is no geometry explain. Girard paper Greg mentioned about interaction, geometry of interaction, something like that. And this paper is by Samson Abramsky, and this Najaran. This paper Greg mentioned.
When is this paper from?
Sorry, what do you mean?
What year was this paper written in?
1997, it looks like.
Oh, Abramsky's got a way more recent version. It's so strange. The one that I have downloaded, I got from Archive, which it says it's from November 2013, but the date on the paper is October 29, 2018. So I'm not actually sure when it's from.
Is it with these guys also, or just by himself?
Just Samson Abramsky. It's called Semantics of Interaction.
Semantics of Interaction. Okay.
Yeah. Yeah. Here I can. I'll share. I have the paper. So. Here, I put it in Discord.
Cool. Thanks.
Mm-hmm.
Oh, you put the paper. Okay.
Yeah.
Maybe I can download it. Yeah, and from this paper, this is like a sequential algorithms are here, and with interaction you have much more expressive power, in different directions. So.
Mm-hmm.
So I'm trying to connect this to Greg's talk about geometry, and
I couldn't pull that up.
I mean, this rholang code is representation, right? Which is algebraic, right?
Mm-hmm.
And I'm missing understanding of geometry, so I cannot. It's really
well. This is weird. I see now where you're going with this interactive computing, but I wouldn't have, it would have taken me a long time to get to this particular investigation.
Because Greg is talk about this for a long time. How this interaction is much more important than just functions. So
Yeah, I developed a language back in the 70s called Interact, which
nice.
which essentially was a proxy to the existing system, where with user commands that that talk to the system below it. So it's it's a pipeline of interfaces.
Okay, so now I need to go read some Abramsky.
But
yeah.
The thing is, quantum nature is only interaction. Einstein said any theory of everything has to be free of singularities, and we don't find any singular action. We see action and reaction. We see action. We see every action has two perspectives, and it's an interaction. Changes the state of the receiver and the sender. There, you can't distinguish the receiver and the sender, except at an abstract level.
So these scattering amplitudes, are they different way of looking at this interaction? I was thinking that I was trying to somehow this relate to to the code, and it crossed my mind that maybe quantum mechanics is like looking at the code. You're looking at the result of the code, and you have probability of seeing semicolon or parentheses, or and you're not looking at the code execution, but you have a theory of parentheses and keywords. And you have some theory where with probability you can say, oh, after that many characters you will see parentheses. And scattering amplitudes is really the problem. This is how I'm trying to understand. Isaac, did you look at the talks about scattering amplitudes by this Nima?
So which one was I watching? I was watching the one, I think he's at, I don't remember if it's Stanford or Cornell, at Cornell.
Yeah.
I got through, I think the first 20-ish minutes is just like his introduction to like his motivation for scattering amplitudes, and I got that far, and I'm already more than lost, and I'm not really sure how to rectify my understanding.
Yeah, I like his explanation from his perspective. He was talking about this Penrose guy and his papers, and he was working in quantum field theory, I think. And he said, I was reading this guy's paper, and introduction, great, everything is nice, super, yeah. A conclusion, great, super nice, great results. And everything in between just, doesn't make sense. It's totally, So he said, this kind of papers, this guy, have written, you know. It's super funny.
Wait, he was saying this about papers that Roger Penrose had written?
Yeah.
Oh, yeah, okay.
And then later, you know, he was predicting some stuff that they were, you know, just amazing, you know. So you know, slowly all the others were just, you know, realizing what this is our important thing. You know?
Yeah.
But at first, you know, it was just, you know, just nonsense, you know.
So I started reading. I mean, it was probably 8 years ago at this point. This one of Roger Penrose's books called "The Road to Reality," and it's like a non-technical introduction to all of the mathematics that you need to understand, like quantum gravity and all of these things. It's like 1,200 pages or something. I mean, it is just like incredible. I can't even imagine somebody writing that many pages. And he has many books. He's still writing books too. Highly recommend it though. I definitely haven't finished, but it's a good read.
Cool.
You know, if you're looking for something to do in your leisure time, you can.
Oh yeah.
1,200 page book.
Yeah,
where
little
every page is like a new insight that you've never heard of before.
Yeah. I feel the same way for these videos from this guy Nima, you know. It's
yeah.
And these Cornell videos are a little less, you know. It's not so much, you know. I find something that I can understand, but what Greg mentioned, this series of videos, this is totally non-understandable for me. You know, it's just difficult to listen, you know, because what? But yeah, these at Cornell are, you know, maybe I can you know, watch a few times and, you know, just.
Yeah, maybe if I were to watch it infinitely many times, I would be able to bring some conclusions away from it.
But as he said, you know, if you can like we are now doing measurement in a collider, you know, it's not feasible that we will get some answers, because we need to build infinitely big collider, but we will create a black hole. So, you know, we can build it in some size, but eventually we will create a big black hole, and then, you know what, we will not have answers. So this is like, you know, we are lost in this direction. So.
Yeah, I've read recently that they made a particle accelerator like the size of like a computer chip. I didn't read all that much into it, but I'm not even sure what that means exactly, because like the Large Hadron Collider is like miles and miles and miles long. So I don't know how you can go from that scale to like a computer chip, but I read that somewhere.
Yeah, in a sense, I see this contradicts to his conclusion that, you know, we need to build bigger stuff so we can, you know, so we can collide this smaller stuff, you know, with more energy. So how to build like smaller particle accelerator? Yeah. Oh, maybe this is just accelerator, but it's not collider.
Well, you can accelerate. You can accelerate one proton, and then you can collide it, right? You know, you don't have to do a lot of them.
Yeah, but to accelerate one proton, you need like giant, you know, track where you can just, you know, speed it up, right?
Well, they're not very heavy. I mean, it seems like you should be able to arrange some kind of a oscillator that would increase in energy.
Oh, you mean you can bounce
Yeah,
this proton between.
right.
But this seems like totally difficult, because now they are using like a giant circle to accelerate it. So if you are just stop in one direction then go in the other, I mean, right? This seems like totally different thing.
Yeah, I don't know how you would put it on a chip, but something like
Yeah.
that.
Yeah. And how to stop it in the other side? Sorry.
I can envision putting a micro accelerator on a chip. I'm wondering, how do you read the results of the collision?
Yeah, exactly. Yeah.
Well, my understanding that the way that they do it now is they have some sort of like gas chamber that the particles interact with, and you can say something based on like the curvature of the paths, like what types of particles they are, but that only tells you like mass information. It's been a really long time since I've thought about all of this stuff though.
Well, if it's just the track of a particle in space, then I'm sure electronically that can be done, fairly. That might not even be a problem. Now, how do you represent the results? It's just a track in space that you represent graphically.
The question is, what is space in for this particle? I mean, it travels almost like the speed of light. So, right.
You want to listen for patterns.
Yeah. Now I see the patterns of the particles flying off. I guess I can say something about the masses and the momentum.
You could be listening for a lot of frequencies, but not all frequencies.
But we are assuming, like when you say frequencies, we are assuming, passage of time and some kind of space, right? And maybe is this the problem? Because we are saying, we recognize this something as a particle, and we will track it in the space, So we are assuming there is a particle, we are assuming there is a space, we are assuming there is a time. So maybe this is why we need some kind of predictability, because maybe there is no particle, but we want to imagine it because we see space and time. So, So I'm thinking that maybe this scattering amplitudes is not looking at the particles, but just, some kind of distribution of energy where, if you are tracking particles, you will see something, right? You will conclude something. But maybe we can look this in different way. Maybe this is why Greg talks about dynamic geometry, where you don't have to stick to some geometry and then try to, somehow conclude what happens. Where maybe you can just change geometry is exactly as happening, and just track this and not the particles, but the changing of geometry.
Yeah.
And from that we can extrapolate time and space and say, this is how time is created.
So you're saying like time would then be some sort of emergent property that's predicated on like the changing of the geometry of what?
Yeah.
space doesn't exist, right? So like what geometry is really changing there?
So he was saying that in Feynman diagrams, you're assuming some
Yeah,
invariance.
Isaac brought up a good point. You've got a dynamic geometry. What space is geometry changing in?
So if this particle is moving through different space geometries, then if you want to track it in only one geometry, this will be difficult, right? Because you will see, oh, it just emerges and then disappears and merges and then disappears, and then yeah, you will if you do a lot of measurement, you will conclude something, right? You can say, oh, there is a possibility that this particle we will see it here. But if you can track the change of geometry, you will get the different conclusion, right? He was saying that in Feynman diagrams, you have this something that is fixed, which causes the problem, because I'm not sure what he means by that. So. But he was
this idea of geometry needing a space to exist in if it's going to change. Is that kind of problematic, because geometry in some sense is the space?
I mean,
is this always the case? I mean, Greg was talking about like magic, when we are going outside of geometry and then you're coming back. So in that sense, maybe you don't need to have something like space.
I mean, I would think of a generative geometry as something that is dynamically happening. And, that if there's a space-time interval, it's defined by some event that exhibits time and space according to a constant. We have space, time and space related in the macrocosm by the constant c. And then we have other dimensions. When a photon enters an atom and goes 10 meters in the atom and back out again, it's at one point in our space, and it exhibits a delay that's dependent on Planck's constant. And that delay instantiates local time, a drag on the universe, so to speak, of this photon that was delayed and scrunched space-time, as well as generated. Contraction locally, expansion globally.
And how to fit in this generative geometry? When you're saying 10 meters, in what space you are talking about? This is
I'm talking about, a space created by events. It's a dynamical space. Okay, so we have space being consume, so to speak. There's a contraction of space-time, that's gravity. And there's an expansion of time-space, that's events. And we lose almost all the information about all the events that have happened since the Big Bang, except that lost information is exhibited at maximum entropy as space itself. So we can, so when we blast off a rocket, we create space underneath it. Because with all this space-time information comes into being. And if we add it all up, there's a lot of space-time there.
Yeah.
It's not all in our 3D dimensions, it's local dimensions.
So when you say create space-time beneath it, what do you mean by that exactly?
Well, every every photon generates a space-time interval, okay, which is some multiple of its wavelength, okay, and that space-time interval creates space. I mean, because it exhibits that much space-time. That's the only way space-time exists, is if it's exhibited by energy.
Why we see space-time everywhere the same? Or is it? I mean, okay, I mean, around the black holes is different, but it seems that, the whole universe is the same space-time. And
well, not really.
Why is that?
I mean, a ruler here on Earth is longer than a ruler out in space. Okay, we're stretched into another direction of space-time.
But if we find the same planet as the Earth, somewhere on another, another place in the galaxy, it will be the same, right? We are expecting that gravity is the same as here, it's right.
Yeah, it's probably the same, but I mean, not necessarily so.
Right.
Okay,
I mean, we really don't know. I mean, can we be sure that, in the next galaxy, the gravity is, I mean, we can calculate, right? But
right. I mean, we have, if we have matter here and right-handed space-time, and we have antimatter over here, left-handed space-time, they logically cancel. And so it's going to destroy a huge amount of space-time.
Yeah.
But so we expect right-handed electrons everywhere. Energy is, photons are momentum exchanges between electrons that define space-time. Either locally by traveling inside an atom, or globally by being across space, because 3D is sufficient for any graph to be expressed, and we have consistency. I mean, the same speed of light, so to speak. In what we consider space. Anything else, any other dimension, we consider time.
Hmm. So you said 3 dimensions of space are sufficient.
Well, there's three locally. There's sufficient. We think a ruler, we have send a 1 foot signal into space, and well, our space and time, there's more space in the inside diameter than there is in the outside diameter. We measure across the inside of space near a mass, it's going to be longer than the outside dimension. So space is created by stretching out or delaying space and into another dimension. It's really as many dimensions as there are atoms. Every atom has its own independent inner dimension. Or drag on space-time, delay, introduces a delay element that gives us memory, gives us persistence.
Where does entanglement fit into this picture?
Entanglement is all there is. Okay, you have, it's just the logical entanglements of things that is the only thing that exists that defines the dimension of space-time. Okay, we have, things have to be entangled because they are defined in that way. In other words, if we come up with a certain polarization of an entangled particle, okay, that angle isn't predetermined. All the information about the polarization is what gives us the orientation. Okay, it's not in some other space, as Gary says. It is space-time. And the only thing that determines orientation is the polarization of the particles. So the correlation of the polarization is what generates that angle. The more over time we get more and more detail as to how accurate that polarization is. But we have a background which is largely random. And we have the delay between when something happens in one location can have an effect in another location. It's how many logical operations distance are they? And clocks are independent by the distance times the speed of light. Or wait.
And when you say clocks are different, we can also say they're in different like space-time geometry, right? I'm trying to connect this to dynamic geometry.
Yeah, at the quantum level, do all interactions change the geometry?
Absolutely. In my view, I mean, that's all there is. There's only we only have space-time intervals that are manifest by energy events. That's it. That's it. That's all we got. There is no other space-time.
Yeah, I've got to read more about these interactions. I'm forever surprised at where these discussions lead, and I look forward to reading that. Maybe I'll have some questions for Greg during the next Casper hour. Thomas
Oh,
Love,
yeah.
have you thought of any?
Yeah. But usually, Greg is talking about something, that I
know
don't expect, and then,
he's off on something else. Yeah,
yeah, I was thinking about these scattering amplitudes, and then he presented this final geometry. It's it's totally different thing. So, yeah.
Yeah, so all of this discussion in the last, I don't know, half hour or whatever, really reminds me of the video that you shared, Gary, of that Hoffman guy, the theory of conscious actors. This all is very reminiscent of that for me.
yeah, I've thought about that as well. Not sure what to make of it, but
Yeah, the question I have for Greg is what he thinks about this constructor theory of information that David Dodge is, talks about, and his computational model, and universal quantum machine, and and I was watching some probability conference at Oxford from last year, I think, and they in one lecture they had like very very how to say, discussion which was yeah, I would like to share this video. Let me find it. Jim, I was thinking, what is your opinion about that?
I don't believe in probabilities. I don't think a probability ever caused anything to happen, ever.
Yeah, it's just like realizing that something is happening, but you don't have any answers. You're just saying, "Oh, I know this."
Information is conditional possibility, not conditional probability. Okay, we choose a history of what possibly could have happened. What was logically possible?
I put the video in the, but I don't see what is the name of the conference. The Wolfson Probability Unconference. Yeah, this is the name.
Did you say unconference?
Yeah, it says unconference. So.
That's funny.
And you cannot see Simon Abramsky, but I think he's on the left side somewhere. I think I recognize his voice. So.
Yeah. Now, unconferences are something. I mean, I don't know if this is really an unconference, but the IIW was an unconference. Okay. The people get. There is no agenda beforehand. People in the morning decide. All sign up for propose different subjects and You know, so it's totally
I see.
has very specific rules to be an a normal unconference.
This makes sense.
So I'll have to check that out. But you know, we have a lot of missing information, and that we're stuck with probability. And the way systems learn, they can pretty closely obey probability curves, whatever. But essentially what happens is an interaction of equal and opposite logical interaction. You know, we can look at it as well. If two electrons could logically occupy the same state, then a photon pair is exchanged between them, and there'll be a momentum exchange between the two electrons. That's all that happens. So it comes down to a Hermitian complex conjugate structure, logical structure, which is essentially equal and opposite action, which is no big surprise, but we thought it would be physical action, and it turns out to be logical action, not physical action. And logic we call entanglement, because logic is instantaneously always the same. I mean, what's logically possible is all possible worlds. And by interaction, we distinguish this world from all possible worlds by choosing a history that we like moving our arm to the left or the right, to have that have happened. You know, against all the laws of physics. Improbable thing happens of this arm with no force put on it, and then whatever.
Yeah, so you mentioned what is possible and what is not possible, and this is something that, you know, David Deutsch is talking about, you know, as something fundamental, you know, what is possible, what is not possible. And you are connecting this to logic, right?
Right.
When you are saying what is possible and what not.
Yeah, it's, you know, what can happen? You know, what are the alternative outcomes of the quantum system? How do we listen for one? How do we tune our radio to receive that outcome as opposed to some other outcome?
This is really interesting. This is so I recently watched this lecture. It's from the Munich Center for Mathematical Philosophy. I guess they have these different talks there, and have like a podcast app that, you know, has like an archive of them. There's like 250 of these things, but either way, one of them was like an hour long about modality and categories. And one thing that he said that just kind of clicked for me a little bit is this notion of a higher order modal logic. And I don't completely know the history, but one thing that this guy says throughout the video is that, like, in the past, people thought that higher order modal logic wasn't complete. And basically what he says is that as long as you allow for your model to vary, and you only need to allow it to vary a little bit, then you can get completeness for higher order modal logic. Somehow that connects with what we're currently talking about. But either way, I highly recommend watching that. I thought it was a super interesting video. He goes through like all of the really basic, like Kripke frames and modal, like propositional logic, and then how categories factor into the situation when you're talking about first order modal logic. And then he starts talking a little bit about higher order modal logic. And one thing that he said at the end that I thought was very interesting, that I had never heard the connection between, that I wanted to bring up at some point in time, and now seems like a great time since I've already primed to bring it up. So he makes this connection between adjunctions between categories. So like between, you know, so functors and categories, adjunct functors or adjoint functors, and these modal operators. And so essentially what he says is anytime you have an adjunction, you automatically get this dual pair of modal operators, one acting just like the box modal operator, one acting just like the diamond modal operator. And these two things form comonad and monad. So the box operator apparently has the structure of a comonad, and the diamond operator apparently has the structure of a monad. And so his thing is that so category theory, the most important idea to come out of category theory is this notion of adjunction. And his thinking is that the reason that's the most important idea is because of this connection to modal logics. And then he basically is like, well, adjunctions are everywhere, and so modal logic is everywhere. And that's kind of like the end of his talk, which I thought was super cool.
Yeah, this is super interesting. I was listening about this connection between adjunctions and monads. They're like isomorphic, right?
Yeah, so with an adjunction, you automatically, you get monad and comonad, but I guess once you have one, you have the dual notion for the other one. Yeah, so it's like if and only if, like if you have a monad, you can make an adjunction, and if you have an adjunction, you can make a monad from that.
Yeah. And now you are saying, you know, you can also have like modal logic from that, right?
Yeah, exactly. Because your monad is basically your diamond operator, and your comonad is basically your box operator, and then that's it. Then you can, you know, then you're off to the races with your modal logic.
Wow, this is totally, you know, unexpected.
Yeah, it's super cool. I highly suggest watching that video.
Can you post the link if you?
Yeah, like I said, I have it on an app, but I'm sure I can find a URL for it. Yeah, I'll post one in there.
Or any something that you know, like a section.
Yeah, definitely.
Yeah, this is super interesting. So if with Ladle, if we have this distributive law between monads, then we have distributive law between modal logics, right?
Say that again.
If we have distributive law between monads, with a ladle. We have distributive law between model logics.
Yeah.
Right?
Yeah, but is there a way to do a distributive law for a general monad? And I think the answer can't be yes, because list is a monad, right? And there is no distributive law for a list.
But Greg is saying that with ladle you can choose, you can take any monad, right? Or you're saying not any.
Well, you have to have one that has a distributive law for it. So like a really nice
okay.
one for collections is set, right? Because there's a really nice, easy distributive law for set, but not so much for list. And they give an example in the ladle paper why that is an issue.
Yeah. You already said that.
I'm going to go to Greg's Q&A now. See you guys. Thank you,
All
bye.
right.
See you.
See you, Jim. See you.
See you. Maybe we